Well, thank you very much, and thank you for the introduction, and thank you for coming tonight. I find very interesting, as just been explained, I used to work for the European Commission, so I'm a Eurocrat, and I now see the effect of Brexit, because the distance between you and me, I think, is quite indicative of where we are at the moment. What I'd like to talk about today is something I've been working on for the past nearly 30 years. Is when I joined the European Commission after working, as was explained, in Cranfield for a while. Then I worked in industry as a consultant for a while. I joined this strange organisation called the European Commission, and I work for the scientific arm of the European Commission. It's called the Joint Research Centre. Has laboratories all over Europe, and its job was to provide the scientific basis for policy. And this was a whole new world for me, because I'd worked as a scientist at Cranfield. I'd worked on the commercial side, doing resource survey for a resource surveying company near London. And now I started to get into this field of mixing science and policy. And it's a weird world. It's a strange world, mixing the two things. It's oil and water. And it's taken us a lot of time to make any progress in there. So I thought it'd be worthwhile just exploring that a little bit, giving you some hint of the problems, but then at the end give you some examples and some solutions about how we have been able to make progress. So when I got to the Commission, it soon became patently clear that politicians and scientists, although in fact in the European Parliament, if you go to Strasbourg, if you go to Brussels, luckily for me, everybody speaks English. And that's great. English is the common language everybody speaks. But scientists and politicians, although they both speak English, speak completely different languages. Completely different languages. What's clear is that scientists have a scientific approach. We start from a thesis, we have a theory, we collect some evidence, we check the evidence, we write it up. It becomes part of the basis of science that all scientists go back to when they go on to do the next step. Politicians don't work like that. Politicians have a completely different way of working. They're cyclical, they're political, they have different drivers. Facts is sometimes an annoyance to their political theory. So when you get scientists and politicians coming together, the potential for confusion is enormous. Even the language. As a scientist, I would be very proud to say that I believe that climate change is caused by humans, and I'm certain to 3 sigma. For me, I'm making a major statement. I'm saying I'm 97% certain that this is the case, that humans are causing climate change. I'm 97% certain. 3 sigma. 3 standard deviations. I tell my friend, the politician in Strasbourg, or in Brussels, or in London, that this is the case. I leave the meeting completely convinced that I have made the most unequivocal case that this is true. A scientist to be 97% certain for a scientist is pretty out there. You know, you're fairly certain. You are convinced you have told this damn politician that this is happening. The politician leaves thinking they haven't got a clue. They haven't got a clue. They're not 100% certain. There's still 3% that could be. They could be wrong. Why am I going to invest in something which is not certain? Language is important. The way you convey information is important. The communication between two such diverse groups of people as scientists and politicians is difficult and needs working on and needs lots and lots of interesting approaches to make it work. As Einstein said, politics is much more difficult than physics, and I can only agree with him. What you also find when dealing with our political masters is that they have lots of opinion. They are politicians. They have political drives. They come from the left, they come from the right, they come from the middle. It doesn't really matter. They have their theories, they have their ideals, which they cling to. Of course they do. That's their job. They pursue their own political agenda. Facts, unfortunately, scientific evidence, if you like, just get in the way. Scientific facts can contradict quite easily the issue that is coming up. And in my first meetings with policymakers in Brussels, the general approach to dealing with science was to say, okay, I have this theory, I've written this policy paper, now can you please provide the data, the facts, that will back up my idea? It's reverse engineering, if you like. Come up with the policy, and then reverse it to find the data which fits the policy. Ignore all that other stuff out there that says that perhaps one or two of the elements of the approach are wrong. Just forget that, but just give me the data that fits my policy agenda. And then they get quite offended when you say, well, actually it doesn't work like that. It doesn't quite work like that. It's difficult. It's a difficult conversation to have. Facts are not always convenient. Facts are not political. Facts are neutral. Facts are facts. Policy is something completely different. And sometimes the tendency of people is to find, like water, to find the easiest route down a hill. And people would deliberately try and find the data that fit what they think and will just ignore the inconvenient truths on the other side. And there comes the friction between science and policy. You see it today. You see it in the debate on fracking. You see it in the debate on GMOs. You see it in the debate on climate change. Everybody likes to quote the fact. My favorite statement, the truth is, Mr. Paxman, the truth is, yes, let's really get down to the facts of things. So we have this kind of Gordian knot. On the one hand, we are a society which is now confronted with increasingly complex societal challenges. I've mentioned climate change, energy supply, water supply, all these kinds of issues, hugely complex. On the other hand, we have politicians who want simple, straightforward answers to these problems. It's an issue, it's a difficulty. Because also within that, it's challenging science. Because the answer that politicians need doesn't come from physics only, or chemistry only, or biology only. It doesn't just come from the natural sciences. There's an economic layer. There's a societal, a social layer. There's a behavioral layer. It's forcing us scientists to think not in terms of our traditional disciplines, which is the way we've been trained, but to think in a multidisciplinary way. And it forces us to start to work as a natural scientist, as I am, or was as I am, start to work with sociologists, to start to work with historians, to start to work with political scientists, to start to work with economists, to start to work with behavioral scientists. And again, that's a whole different layer of language, a different layer of communication, a different way of working between different bases, different experiences. Very, very challenging. We have to break that knot. Let's give an example. Let's give the example of the organisation I used to work for, the European Commission. What does the European Commission do? It sets laws, it sets legislation, it sets regulation. It has to be neutral. All these things. It sets policies in a whole range of complex areas: health, agriculture, regional development, environment, climate change. All these areas it has to set policies for, complex areas. It needs a basis to be able to do that on. It needs a factual basis. It needs the facts to be able to persuade 28, soon to be 27, member states as to the way forward. It's complicated. Sometimes what's needed is just one number. If you're doing a regulation or a standard, if you're doing a regulation, sometimes you just need one number, one figure, one value to put into the regulation. Sometimes it's the basis of the whole regulation, it's the basis of the whole legislation. If you're doing health policy. Let me give you an example. I've been very fascinated recently with the whole area of additive manufacturing, 3D printing, how it's going to affect the manufacturing process, how it's going to change the manufacturing process, how it's going to change the value chain. Then I started to get interested in the health side of that. And you start to see that over the past 24 months, 36 months, the scientists, the technologies have moved at such a rate that now they are printing human cells over burns to reduce scarring. They are printing kidneys. They are printing livers. They're starting to print hearts. How does government respond to that? What regulations need to be put in place? What legislation needs to be put in place? Does anything need to be put in place? Are there health and safety issues? If you're going to have your kidney printed, probably you'd like to know that it's been printed to a sufficient standard it's going to work. How do you do that? Science input into policy. Now, theoretically, it should be fairly straightforward. Policy, theoretically, follows a cycle, a circle. You anticipate something. Let's give the example of the additive manufacturing, the printing of kidneys. You anticipate it. You analyze it. On that basis of the analysis, you formulate some policy. You adopt the policy. In this case, it would be the European Parliament and the Council of Ministers that would take the proposal of the European Commission and implement it. You would implement it, and then you would evaluate it. And science steps in at each step of the way. It helps to anticipate. It brings forward issues, scientific issues, that are going to potentially affect society. It analyzes it. Science as a whole analyzes it. You formulate policy in which science has an input. You adopt it. The implementation has a scientific base, and then the evaluation, the impact assessment, as they call it at the European level, is then undertaken by scientists to see what actually happens. Beautiful, nice and symmetrical, but of course, it doesn't work like that. This is the additional level of complication, because nothing in the policy level, nothing in the scientific level works in that perfectly sane, logical way. It's complete interaction. It's a little bit of chaos. We go forward 2 steps, we go back 1 step. We have to look at the anticipation again because new evidence has come to bear. That will impact the policy adoption. We have to talk to a whole range of organizations, industry, NGOs, political parties, scientists, whoever, and the interaction goes on and on. So what we're dealing with is not a stable situation either. It's hugely complicated. And if you look, I don't pretend you're going to see that, But this is a friend of mine in Brussels who worked in the health industry, in health policy, drew this map of how health works at the European level. So you're dealing with a map that looks something like that. It's complicated. How do governments cope with that? How do governments cope with providing scientific input into the policy-making process? Well, people have completely different approaches. Everybody knows about national academies. We have the Royal Academy. Other countries have similar organizations. They have a role. There's also, most governments have advisory committees. You'll see at the European level, at the British level, there'll be specific advisory committees looking at different subjects, examining them in some detail, bringing experts around the table, hearing evidence, bringing together reports and so on. There's advisory councils. At the European level, you have one of those now. Japan has one. The United States have one, where the Prime Minister, the Premier, the President will have his or her own council that reports to them on scientific issues. And quite a few countries now have what are called chief scientific advisors. Britain was one of the first. We've had some remarkable people. Sir David King was one of the ones that was Walpole is the current one. Remarkable people who have a very broad scientific basis, who call upon different departments and different specific scientific advisors to bring that advice together and report to premiers or presidents. What you tend to find is that most countries, most organizations have applied more than one of those. Very few just have one of those models active. Most countries have more than one operational at any one time. And what you also find is that they are working in two different modes, because when you are working at the science policy interface, you are, in the main, responding to questions from policymakers. Question, I'm developing a new policy for agriculture. I want to be able to measure yield of 6 European crops 3 months in advance of harvest. How can I do that? I need to be able to do that. How can I do that? Science responds. What's the evidence? New development techniques are developed. But occasionally, you get the push, as I explained with the additive manufacturing example. Sometimes scientific issues, nanotechnologies is another, GMOs was another. GMOs we got horribly wrong. The science was good, the behavioral and the economics and the sociological was very, very bad. Nano is one that's coming through now. Genomics is another issue which is coming through. You can already see it. The Sun newspaper or the Daily Mail, if we get the argument wrong, if our behavioral scientists and our sociological scientists do not help the natural scientists on genomics, then you can see that the next title, the next headline of the Daily Mail would be Frankenstein's science, because with genomics we are able to play around with the DNA of humans, of plants, of animals. And you can see the potential for misrepresentation in the press if you're not careful. So sometimes it's scientists interacting with politicians. In the main, it's politicians asking questions of science. But you have to remember there's a balance between the two. And there's a critical difference between the two as well. So how does it work? What are the basic principles that you need to be able to provide good scientific advice into the policy domain? Well, the first thing is you must be independent. Because, again, climate change, tobacco, smoking. First accusation is, you're working for the oil companies or you're working for the tobacco industry. You have to be independent. The science has to be independent. It cannot be questioned. Second thing is you have to maintain trust. And sadly, over the past couple of years, you're seeing that trust questioned. President Trump keeps talking about fake news. It's an attack on trust. And people are questioning economists regularly on economic models. Every time a new economic prediction comes up about Britain leaving the EU, everybody says it's rubbish, you can't trust it. It's a dangerous trip to go down. Scientists must protect that trust at all costs, because the moment you lose that trust, then we're in deep, deep trouble. You must report to the top. It's no good giving your scientific evidence to somebody sitting at a desk somewhere. It's got to be to the president, it's got to be to the prime minister, it's got to be to the top, the decision makers. Have to be able to differentiate between science for policy and policy for science. I worked for the Joint Research Centre, which were a bunch of laboratories providing science input into policy. My good friends in DG Research and Development do the opposite. They do the European Union policy for science. They set the agenda for Horizon 2020. They will be writing Framework Programme 9. That's science. That's policy for science. You must seek to inform, but you must not seek to write the policy. We have politicians that write policy. Scientists should never, ever, ever, ever write policy. It's not our job. We're not skilled at it. We can provide all the evidence you want, but there must be clear blue water between the evidence that's provided by science and the policy that's written by policymakers. Never muddy the water between. You should always recognize the limits of science. People regularly, and I hear presentations, oversell the capacity of what science can do. I don't think we have to exaggerate too much at the moment because science is making such enormous steps forward. But you do hear it, and it does science no favors, and again we come back to fake news if we're not careful. Engage with the scientific community. The breadth of scientific evidence out there at the moment is enormous, and I'll come back to that subject in a minute. It's huge. You must engage with the scientific community to be able to get a gauge of how big that evidence base is. You must engage with the policy community, of course, and you must answer the question. The first thing you're told as any student, answer the question. Too many times we like to come back and show how clever we are and give them huge range of information which nobody is interested in and just confuses people. So what are we dealing with here? Well, I've tried to summarize it in a little diagram like this. And we're in an interesting period because science is going through turmoil at the moment. We're going through a big period of change. We have something called big data. With the new techniques that we have at the moment, with the new developments we have with instrumentation, our ability to collect and manage data is increasing at an exponential rate. We have huge quantities of data out there. Added to that, we have something called citizen science. When I started my scientific career working in Earth observation, I specialized in synthetic aperture radars. The population of people working on that in the world was around about 10 to 12. I knew them all. I drank beer with them, which is the basis of all good science, as you know. We knew each other. We knew where the science was going for each of us. We knew what was going on. Gone. That period has gone. In any given field now, the number of people working in an area, and it's down to the fact that on the one hand, you have new scientific communities starting in India, in China, in other countries where huge amounts of science is coming up. On the other hand, there is citizen science collecting huge quantities of data. The RSPB use it regularly to collect data. You also have open access. No more protecting your data sets. Everything is now available to everybody. It's making a lot more data available to people. And you have questions on scientific quality. Recent papers coming out in Nature and so on are questioning the validity of huge numbers of scientific papers at the moment. Are they valid? Are they repeatable? So we have huge amounts of interesting subjects to address, but huge amounts of problems to address on the scientific side. On the policy side, you have a different set of issues. You have complex societal challenges, as I mentioned just now, and I'll come back to in a minute. Things that require multidisciplinary science to be addressed. You have time-limited needs. A politician always requires the answer yesterday. Science, as you know, takes years and years and years and years. If you want to start a new department in the University of Wolverhampton, it will be 10 years before you have a department which is internationally recognized, at least. You don't start new subjects and come to an answer. It's a conflict between the two. How does that work? A lot of what they want is multidisciplinary, as I said earlier on, and it's evolving. They give you a question, and then 2 weeks later, the question has evolved because they talked to somebody else over there, and they want to add something to the question that they originally posed to you. And they want clear, accurate messages. As I mentioned, the 3 sigma. They want language which can be understood. A lot of my colleagues in science, even in the Joint Research Centre, think it's quite sufficient just to be able to give them a paper they just published in Science or Nature and say, there's your answer. No, it's not. It's not at all. It will not help. It will only confuse. You have to give clear and accurate messages in language that people can understand. Scientists are really not very good at doing that. As I said, the scientific population is increasing. This is an analysis. It doesn't matter. It's a lot of pretty lights. But what it actually shows is the number of people working on a particular scientific subject, quite a restricted scientific subject. It's all about biochemistry, a particularly genomic subject. This is the number of institutions that were found who had been working, who had published articles on that particular subject. That's a challenge that we're facing. That's a challenge. So when someone says, what is the answer? What's the scientific answer to this question on genomics? This is the population of scientific institutions that you have to deal with. Not only that, you have huge quantities of data to bring together, to analyze, to say, this is the direction of movement. This is what we believe to be true. This is what we want, the message that we want to give. And this is not easy. This is not straightforward. When you're confronted with the huge range of scientific evidence, where do you draw the line? How do you draw the line? It's a trick. It's really to know which part of that Gaussian curve do you throw away and say that's outliers, which bit do you say, yes, that's the way forward. Because in any scientific subject, it's not often obvious what the answer will be. There is always a range of opinion. There's always outliers. Not only that, what you're beginning to find is that different organizations, NGOs, industry, of course, scientific academies and universities, all have their own scientific capacity. Greenpeace has a huge scientific capacity. They have their own scientific evidence. How do you treat that? How do you treat scientific evidence coming from the oil industry? How do you treat scientific evidence coming from the tobacco industry? All science, all published, all in the journals. How do you treat it? And this is just to show that the scientific challenge, these just happen to be the societal challenges in Horizon 2020. It's not really very important where they come from. It's just to show that these are the sorts of subjects where politicians today are really becoming excited and want answers. As you can see, multidisciplinary, complex. Okay, so that's the problem, that's the issue. Let me give you some examples now of how science has actually input into the policy-making progress. And I'm going to be very biased now, which is what I said I shouldn't be, but I'm going to be very biased now because I'm going to use examples from my old organization of the European Commission. This is the work, some of the work of the Joint Research Centre. The Joint Research Centre, for those of you who don't know, is a bunch of about 2,000 scientists who work in 5 laboratories across the European Union, doing science in a whole range of subjects. So basically they have to address all the different policy domains of the European Union. So health to demographic change, to climate change, to waste pollution, to agriculture, to whatever. They're doing a huge amount of work to try and understand that. And they also have to work with a huge number of partner organizations in order to be able to gather all the evidence that they need. Not only that, they've been forced down other routes to look at ways to gather the information that they need. They do a lot of horizon scanning, a lot of foresight, to try and establish what up-and-coming issues are going to hit society. As I mentioned, additive manufacturing, genomics, whatever it might be. They look for policy options. They don't give policy, they don't write policy, but they'll say that the scientific evidence shows that within here to here, that's your options. You can work within that domain for your policy development. They look at, they're doing, and these are all natural science. They have been up until now, mainly natural scientists in the Joint Research Centre. Now we have a lot of economists working with us, modelers obviously, a lot of sociologists, behavioural scientists working with us. Makes it a very interesting and stimulating, not always easy, environment. Different disciplines don't always work smoothly together, though it's getting better. They do a lot of work on standardization, because standardization is one of the main inputs that we can be used into policy making, and of course they do laboratory-based science. Let's look at the example of agricultural policy. When I first joined the Commission back in 1988, I'm looking around the room now, and there's one or two of you that might remember this. But the big issue was that Europe was either producing far too much food, wine, milk, and olive oil, or it wasn't producing enough food, wine, milk, and olive oil. There were either food mountains and milk lakes or wine lakes, or there was a complete shortage. And this was a scandal. The Daily Mail used to love it, I remember. You would always get lots of discussion about the food mountains in Europe and the wastage and everything. Or they were going on about hungry people or food prices going up because we had to import it from other parts of the world too late when the food prices were too high. So what our friends in DG Agriculture, Directorate General Agriculture, needed, was a methodology that would predict crop yield well in advance of harvest. They wanted it sufficiently in advance of harvest so that they could play the food markets and buy in or sell on the commodities in due time. And they wanted this for a set number of crops. And so the challenge was, and it started in 1988, the challenge was to build a process based upon good science that would allow them to do that. And this was done. So what was used was a whole range of different techniques. Earth observation from satellites to be able to measure the crops. Meteorological models to predict how the crop would grow based upon good meteorological data that was collected across the European Union. And as a result, after a number of years, we came up with a process to do that. It's now been adopted by all 28 member states. It is now applied by all 28 member states. And as a result, the Daily Mail can no longer publish nice stories about food mountains and wine lakes, so they publish lots of other stories instead. I'm not particularly picking on the Daily Mail, it's just I don't like it very much. What they're doing now is moving that onwards to global prediction. So for a selected number of crops, they are now developing the model so that we can predict crop yield across the globe. Not for so many crops, but still enough of the basic crops so that we can start to say there is going to be starvation in this part of the world if we don't do something. Instead of waiting for it to happen, which is generally the case, and you get the horrible pictures on the TV of kids starving. Hopefully now, and we're getting there, we will have advance warning of that, and hopefully our policymakers will be proactive enough to act upon it so that we don't get those horror stories anymore. Another example is regional policy. Regional policy is agriculture is the biggest fund in the European Union. It costs the European Union something in the region of 120 billion euros a year. Territorial policy is the second biggest, around about 50 or 60 billion, a small amount. Here you're getting investment. In fact, we were talking just now about NTRES here. That was funded by regional policy. A good example of it. But what the European Union needs to know is if it invests 1 million in the port of Marseille, or let's get a little bit more serious because the regional fund very seldom only invests 1 million. Let's say it invests 50 million euro in developing the port of Marseille. What is the social and economic impact of that on Marseille? Is there going to be any benefit? And as importantly, what is the social and economic impact on other regions around Europe, in a positive or a negative sense? And again, we were asked to develop that. We were asked to be able to map. We were asked to be able to monitor the impact. So we have now developed a model that DG Regional Development, DG Regio, now use. It's part of the whole smart specialization package. I don't know if you've heard of that, which allows regions to say, okay, we want to invest in here, because the decision on where the money is invested is taken at the regional and national level. And then you can run the model and say, okay, if we invest that 50 million in Marseille, this is going to be the economic impact, this is going to be the social impact. And this is used extensively now, and it's used to go against the attack that often happens about the use of money in regional development, which is often seen as corrupt and so on. Well, hopefully this will go some way to addressing that issue. Here's a third example. This is about disaster monitoring. This is about fires and floods. So again, using Earth observation data, using meteorological models, using land use models as well, soil erosion models, soil maps, we are able now we run this across the whole of the European Union. We work with the member states and the regions, and the idea is to be able to predict when a flood is likely to happen or when a fire is likely to happen, so that again we don't get the nasty surprises of the Danube flooding and causing huge amounts of problems in certain parts of Europe or whatever might be. And this is something that's been working now for a number of years and it's been improved. It's part of the whole disaster monitoring program of the European Union and seems to be working quite well. This is another type of support that science can provide, because when you're making policy, when you're trying to put down policy for something as big as the European Union or something as big as the United Kingdom, you need baseline data sets which are coherent and accurate. You need to have the underlying data set. This is just one example. This is soil. And I put it in there because I worked in soil science for a little while. It always fascinated me. And I never thought that this would be possible, because when I was working in the area in the early 1980s, the thought of having a global soil map was incredible. The arguments, the differences in classification, it would never have existed. It's now been developed. We now have a global soil map, and the different regions of the world have now been mapped for soil. This is a baseline data set along with land cover or land use or hydrology that can go into a policy-making process and improve the adoption and implementation of any spatially based policy. Here's another area that this is a direct request from the European Parliament. The European Parliament cares deeply about the use of animals in the testing of any new product. I don't know if you heard just recently about, again, the diesel story and monkeys. Horrible. This is a whole example of how the Parliament asked the Commission, therefore the Joint Research Centre, to come up with processes as part of its chemicals policy, as part of other policies, so that methods are developed which do not, under any circumstances, use animals in the production of that product. Far from completed. Huge amounts of work to be done, but lots of good work already done and out there, and methodologies adopted so that we can have validated models, because that's what can be done at the European Union level. You can have models which are validated across the European Union. So they're accepted, they're tested, they're accepted across the European Union. Huge amounts of progress. GMOs are a big failure. And this is perhaps an example of how not to do science and policy. Science was good. Science on GMOs was good. Very good science. Europe had a very strong GMO industry, but the sociology, the economics, the behavioral science was very badly done, and the argument was completely lost. And as a result now, and you may agree or disagree with this, this is entirely up to you, but we now have no GMO industry in the European Union. And it's all done in South America, North America, other parts of the world. So, whole range of subject there. Nanotechnologies is an interesting one, because at the moment, policy doesn't know what to do with it. Policymakers are struggling with this subject. This is one of the new subjects that I was talking about that's now popping up. Not so new, actually. Nanotechnology has been around a long time. It's just that policy takes a long time to catch up sometimes. And as I mentioned with additive manufacturing, it's always several steps behind. Sometimes that's a good thing. But here, it's very interesting. So you can break the work down into kind of three basic bits. First one is understanding nanotechnologies. And in fact, it's taken the European Union almost 10 years to define what a nanotechnology, what a nanomaterial actually is. 10 years to get to the point where we have a definition which is agreed. And that's an interaction between scientists and politicians to come to something that the European Parliament can take and vote upon and accept. We're now there. So we're beginning to understand what nanomaterials are. Second thing that we start to do now is safety assessment. What happens if you put nanomaterials into your eyeshadow and you put it on your eyelid? What happens? Is that a safe thing to do? Do you want those little nanomaterials to enter your eyeball and wander around inside you? Do you want that to happen? And if you do let that happen, what happens to you as a result? That kind of safety assessment is the interaction between science and policy. Scientists find out what happens, policymakers regulate. If we find out that the materials that they're putting on in the eyeshadow are doing horrendous damage to the eyeball or other parts of the body, then you regulate. And that's the interaction and the way it starts to happen. We're still a long way from getting there, but we are starting to work on that. And the last bit that you do is the innovative research. This is more like the push. This is where you're finding out, where can this technology go? What can it do? What's the policy implication of where it can go? And the last example is one that I always put up, mainly because it scares me a little bit, actually. It's about nuclear safety and security. As you know, the European Union has the Euratom Treaty, which is there, signed at the same time as the Treaty of Rome, as I'm sure you all know. And it's there to make sure that all our nuclear reactors and our nuclear processes within the European Union are safe and secure. Unfortunately, the UK has now pulled out of the Euratom Treaty. But it's there, and one of the things that has to be done within the Euratom Treaty is that all nuclear materials are tracked. We know where all fissile materials, all nuclear materials are, where they're located, how much, how long they've been there, and what's being done with them. Now that has to be checked. And the borders are checked all the time to make sure that nuclear materials are not being transported unbeknown to the powers that be across those borders. And techniques need to be developed to make sure that that checking can take place. Again, that's been done by science. It's input into there. What kind of scares me is the amount. We've had 300 confirmed cases of illicit trafficking of radioactive material over the past, and 215 of those cases have been over the last 5 years. It worries me somewhat that it is that level of activity, but that's just a personal thing. So again, an example of how science and policy actually can work together. So to conclude, what I'd like to leave you with, really, is the feeling, one, is that science is moving forward at the most fantastic speed, huge quantities of science, good science. Second is that policy is trying to catch up. But mainly is that the interaction between science and policy is, one, crucial in modern society because of the challenges that we face. Two, is difficult because of the different training and character, if you like, of scientists and policymakers. And it takes a lot of work on both sides for the two communities to come together and understand each other and make use of one another, because they can make use of one another. It's a difficult subject, but it's a very worthwhile subject when you get it right. So at that point, thank you very much for listening, and thank you for attending tonight. Thank you.
Thank you very much, Peter, for this excellent presentation. We have an opportunity for Q&As. I'm not going to come up there.
No, you have to bridge the gap between the European Union and the UK over it. I'm going to repeat your question because I've been asked to do that because you're not being picked up on the microphone. So the question is, and correct me if I get it wrong, the question is, do you think that by leaving the European Union, the UK's scientific structures and input will be weakened by the Brexit. Yeah. In my opinion, I think it very much depends on the way the negotiations go. The first thing to say is I worked in science before the Berlin Wall came down and the Cold War was still in place. And scientists worked transparently. I worked easily and well with Russian, Ukrainian, Chinese scientists and continue to do so. So science has a wonderful way of breaking through political structures, whatever happens. But that doesn't really answer your question. I think unless the UK and the European Union can come to an agreement whereby UK science can participate fully and openly in the research programs of the European Union, then UK science will be weakened and European Union science will be weakened. Because what UK gets, UK is one of the most active participants in the research structures of the European Union, one of the most successful. And if you look at world rankings of universities, UK, of all European Union member states, is by far the best. However, what the UK gets is partnership. It's money, of course, it's grants, of course, and it's the funding of doctorate, postdoctorate students, it's the funding of laboratories, of course. But the real benefit for the UK, for me, is partnership. And I think if the UK is cut off from the European Union programs, that's what it will really lose, is the partnership. And the partnerships are extremely well formed now. And I think if you talk to all universities, they're seen as being extremely beneficial. So unless the UK government, and to be fair to the UK government, they do regularly say that one of their ambitions is to remain a part of the research program of the European Union. If they can't achieve that, I think it's going to be problematical for UK science.
I wanted to ask about the divide you've got between science and policy. Clearly important. What about ethical concerns that could arise from scientific discoveries and how they would then inform what could be perceived to be bad policy?
Yeah. So the question is, how do we manage ethical concerns from developments of science? How do we manage that? I think it's a very good question, and I think this is one of the reasons I put that little box up there about science not exceeding itself. Scientists have, in my opinion, and I'm one of them, have huge egos, and they become quite single-minded, and will quite happily follow a route of science and not think. Some will not think too carefully about the ethical considerations. I think that's another reason why we need to involve civil society, we need to involve politicians and policymakers in what we do, because the way science is going, I raised the subject of genomics, and I don't wish to be light-hearted about this, because you are starting to deal with very, very ethical issues. And science could quite easily go down routes which society really doesn't want ethically it to go down. And I think it's really important that link is maintained. I think it's really important that scientists do not set the ethics. They are part of the discussion that sets the ethics, but it must be society that sets the ethics for where science can and cannot go. Because there are all sorts of considerations in there that have to take place. And it's a very, very important discussion to have. And we're hitting it on a number of subjects.
Do you believe that there is a conflict between culture and belief between science and religious?
I'm sorry, you're speaking quite quietly. Is there a conflict between...
Do you regard there is a conflict between the science and beliefs and culture?
Yeah.
Even especially in the Arabic countries. And does that affect the relationship between the science and policy or not?
Yeah, and it's not just in the Arabic countries, it's in this country. You're always going to get that. People, civil society has beliefs, and quite rightly so. And the beliefs can be quite diverse. But it will affect policy, and that will affect the science that can be undertaken, for sure. And I don't think you can avoid that, and I don't think you should avoid that. I think that's part of society, and it's part of the discussion that has to take place between science, the policymakers, and civil society in general, because people have to be happy and believe in the science that's been undertaken. And as I say, that where science is going now in different areas is so out there now, so touching the soul of humanity. You're touching life itself almost. You have to take the ethics of the people who are funding you, because that's society. You're not doing this for free. You have to touch the soul of those people and be content that they are giving you the guidance as to where you can and cannot go. You see it on stem cell research all the time at the moment. And that's an absolutely valid discussion. And don't let the arrogant scientists tell you where to go with your science. Don't let that happen, because I'm a scientist. I completely believe in what I'm doing, and I believe it's completely the right thing to do, and it's benefit to the world. But society can say, no, hang on, we don't want you to go down there. And there's lots of good reasons. And science doesn't have a pure record in this area, and should always be held to account by society, always.
Can I just ask, reflecting on your background as a sort of, dare I call you a social scientist by your sort of first training, if you like, and then moving into sort of science, what are we doing right in universities, and what are we doing wrong in universities? Are we doing enough interdisciplinary, multidisciplinary work? What are we getting right, what are we getting wrong?
So the question is, what are universities getting right and getting wrong in the education of young people with respect to science? I think it's a really good question, and it's something I've thought a lot about. I was quite lucky in that my first degree was in history and geography, which, and in fact it was a Bachelor of Arts. So it wasn't even a Bachelor of Science, it was a Bachelor of Arts, it was a BA. So it was a bit of a problem when I started working in science, because I had to completely reconvert. But the benefit was that I'd read a lot of philosophy, I'd read a lot of political science, I'd read a lot of history, and that gave me a really interesting basis. And if you look back 100 years, 150 years, our great scientists were also our great philosophers in many, many cases. And what they were doing had a very, very strong philosophical basis, which you could agree with or disagree with, but they had a philosophical basis. I think at the moment, I meet too many scientists who are quite proud of the fact they don't read books, if you see what I mean. They don't read, they read the papers, but they don't read about the philosophy, different philosophies is whatever. And I think probably in the UK, we make our kids choose very important subjects a little bit too early. And I think the ability to have a broader education a little bit longer, where people read a little bit, and so, you know, I have a great friend who writes entire papers where there are 3 words and the rest are equations. Great mathematician. But you need them also to have a philosophical base. And you find that the really great scientists still have that. But I think we're getting something right, because British science is still producing some of the best scientists in the world by a long way, and we're doing it much better than every other European Union country, and we're up there with the United States and now China and other countries which are coming through. But I would just love to see students have a broader basis to their science than they currently have.
Going back to GMOs.
Oh, yeah.
I understand what you said about the science succeeded and the social marketing, whatever, failed. Is there a way back on that, or is that done now?
So the question is there a way back from the situation the European Union has on GMOs? I think it would take an earthquake of proportions never seen before to move the European Parliament and the people of Europe away from the current GMO position at the moment. I don't see any evidence that there is any political desire to change that position. In fact, what you're seeing is regulation being put in place to harden the borders around the European Union with respect to entrance of GMO-based crops from North America or wherever coming into the European Union. Lots of methods being developed to detect GMO crops, well, GMO food-based food when it comes in. Also, we've stopped a lot of research on the impact of GMO-based crops on the environment. So I think it would take a really massive earthquake for that to happen. I see no evidence of it happening at all at the moment.
Can I follow that up then and say, are there other areas of science where the same could happen, where there's an opportunity to head that off before we reach that tipping point?
Yeah, it's a very good question, and it's oh, let me ask. I'm sorry, I have to repeat the question. Is there any other areas of science where the GMO situation is likely to happen? Yes, the simple answer is yes, and I think with the rapid development of science, and it's breathtaking where science is going. I mentioned the whole area of additive manufacturing and health. I think when the population catches up with the fact that we're printing body parts now, we're printing kidneys, and soon they will print the very first heart. I mean, it's not maybe they've already done it, I don't know, but they're printing cells. Once that hits, you can see the potential for people to go, oh my God, is that what we want to do? Second one is genomics, the whole area of genomics where you're playing around with DNA, you're changing DNA, you have the ability to have medicine based upon your genome, you have the ability to change, to have babies how you want them, whatever that means. And we come back to the cultural question, which was answered, and the ethical question. You have all sorts of, and as I say, you can see the title Frankenstein science coming up very, very quickly. Nano has another potential. If you get the fear factor in there that people are using nanotechnologies and those particles don't recognize skin, they just travel straight through it. Once you get that across, you can see how that could go horribly wrong. So you see whole different areas, I think, of science where potentially, if we don't get the package right, and most importantly, we don't put in place the regulations to make it safe, and most importantly, if we don't address the ethics which concern a lot of these technologies, genomics being the classic example, then we are going to have a problem. And I think we all have to work very hard to make sure that we don't lose another whole area of science and technology because we didn't do the right thing in the wider civil society. Who can be truly independent? Sorry, I didn't hear. Who could be truly independent? Yeah. But which type of person should be a scientist? Yeah, it's so. How can you? So I'll repeat the question. How can any scientist be considered truly independent? Is your question? I think it's a very good question, and you can do it. I guess if you look at any individual, you're going to find biases. I certainly have my biases. You've heard some of them this evening. I don't like the Daily Mail. There are. I'm very pro-Europe. You, as you can imagine. So everybody's going to have their biases. I think all you can do is try your very best in your scientific work to place yourself beyond the if you're funded by industry to look at the emissions coming from an engine, then people are always going to ask, really? If I'm funded by the tobacco industry to look at the effects of smoking on a body, people are always going to ask. So I think you have to be very, very conscious of who you're working for. So I worked for the Joint Research Centre, which was independent by definition. You're working for a university, which is generally considered to be independent, if you're not taking funding from industry to do your work. So you just have to think all the time. If I want to have this role of interfacing with policymaker, if I'm going to be the one that's going to have that discussion with the mayor of Wolverhampton or the Prime Minister of the United Kingdom or President Juncker or whoever it might be, then you have to protect yourself, because someone will surely find out that you were funded by XYZ or you worked for. So I think the only way to do it, I don't think there's any hard and fast rule. You just have to be extremely careful about who you work for and where you take your money from. And be careful what you publish on Facebook.
I'm a bit reluctant to ask this question, but thank
Oh
you
dear.
for coming around this evening.
Right.
Single greatest threat to global energy security is the lack of political engagement with the scientific community on investment into biotraffic engineering design education. Over the next 30 years, we face global depopulation that exceeds all wars since the Industrial Revolution began. What do you think is the best approach to mitigate eventual collapse of the oil industry in this regard?
Of the oil industry. Gosh, there's a. So how can we? The question is, how can we mitigate against the collapse of the oil industry and the consequential economic and social problems? That's what you.
It's investment into the engineering design for new energy systems that don't exist.
Wow, that's a question and a half, isn't it? That's because you are facing an uphill battle. If you listen to the policymakers at the European, to a lesser extent at the UK level, all the discussion is about exactly what you're talking about, is investment in alternative energy sources and alternative technologies. I think the only way to protect it in the current political climate is really to focus on mitigating the damage of oil on the environment. And I think you're going to have to carbon capture and storage and so on, all these kinds of technologies which have been avoided a little bit by industry, should really become the focus. And you should snatch the green mantle as much as possible. I don't know if I'm answering your question, but from the look on your face, I don't think I am. But maybe you could ask it a different way and I'll try again.
With the eventual collapse of the oil industry, because we know that fossil fuels are a finite resource.
Yes, for sure, yeah.
The issue is not so much sustainable energy, but finding alternative energy sources.
Yes.
There is no investment or political talk.
Oh, I see what you mean. Oh, I've misunderstood your question. I'm really sorry. I misunderstood your question. So the question is, with the collapse of eventually the collapse of the oil industry, because it's a finite resource and it's going to run out at a certain point or become too expensive to extract, then we need to invest in other energy producing industries to replace it. Yeah, it's a good question. I think if you start to read something like the SET plan, which is the Strategic Energy and Transport Plan of the European Union, and that's just been recently updated. I think there's a Strategic Energy Plan as well now. You'll start to see that there's a whole plan in place now which is non-carbon based. And it looks at everything from hydrogen as an energy source all the way through to the ones that we know with wind, wave and everything else. And it goes down to a plan which, if I was listening on Radio 4 today, which is really not happening in the UK at the moment, which is a whole kind of smart metering where you have multiple thousands of energy sources rather than one or two or three big energy sources. And it goes through the whole plethora of the different technologies that are needed, and it puts together a plan for how those energy sources and energy technologies can and should be developed, and the funding mechanisms to make that happen. So it's starting to happen at the European level. And it's been happening now for the past, I think the first SET plan was about 10 years ago. And you're seeing all sorts of investment. And if you look at Horizon 2020, huge amounts of money are being put, research money are being put into alternative energy technologies and alternative energy sources. So I think it is beginning to happen. In the even the UK, which has always been a strong oil-based economy, you're starting to see shifts. Even with this government, you're starting to see shifts. Maybe not as much as you would like, and I would tend to agree with you, but you're starting to see shifts. Have a look at the European plan, see what you think, and I think throw all weight behind that, because I think it does provide the answer to the question that you have.
I think that's a great start. Thank you.
Yeah.
Okay, if there are no more questions, that just leaves me to once again thank Peter for
pleasure.
coming here today and for giving us a hugely inspiring talk and for answering some pretty tricky questions at the end.
Yeah. Thank you very much. Thank you for inviting me.